Hi, welcome to this NETSCOUT session here at AWS reInvent 2020, Safe and Successful AWS Migrations. I'm Ray Krug, Director of Product Marketing for NETSCOUT, and look forward to talking through how NETSCOUT provides visibility for these successful migrations. So, Michael, over to you to set the stage.
Thank you, Ray. And welcome everyone, and thank you for joining us today. My name is Michael Segal, and I'm the Area Vice President of Strategic Alliances here at NETSCOUT, working very closely with AWS on developing a strong technology and business foundation to enable our joint enterprise and communication service provider customers to embark successfully on their digital transformation journey. And indeed, as an advanced AWS ISV technology partner with network competency, migration competency, and both commercial and GovCloud AWS marketplace offerings, NETSCOUT is uniquely positioned to help our customers migrate their services to AWS with confidence. And with that said, let's take a look at our agenda for today.
In our presentation today, we will review the business needs and technical requirements that drive enterprise IT to accelerate their migration to AWS. We will look at the best practices of using visibility and service assurance to successfully migrate service workloads to AWS. We will discuss how to get to day 2 post-migration cost-effectively with smart visibility from NETSCOUT. Then we will demonstrate how NETSCOUT Technology Foundation is put to practice in use cases of successful AWS cloud migration with NETSCOUT visibility across the hybrid cloud environment. After that, we will introduce enterprise 5G and edge computing use cases, and we'll wrap it up with a deeper dive into the NETSCOUT and AWS specific collaboration areas. This next slide illustrates the fact that organic correlation between hybrid cloud adoption and positive business outcomes has been magnified by COVID-19 and extended need to work from home, which in turn accelerate the adoption of the cloud-based IT model. Other two interesting points worth mentioning on this slide are that the borders between private and public cloud are dissolving, and the new boundaries of the hybrid cloud are extended all the way to home. Successful adoption of cloud-based IT models would require enterprises to migrate service workloads from their on-prem environments to the cloud while continuously delivering services to customers and end users in hybrid cloud environments. This migration creates service visibility challenges across silos and borders of management and monitoring domains. As you can also see on the slide, according to IDC, many enterprises are dissatisfied with current hybrid cloud management strategies and as a result have day 2 post-migration operational concerns. This next slide illustrates the key stages of safe and successful cloud migration. The first milestone happens on day 0, pre-migration, and is focused on discovering all the dependencies of the on-prem services and their respective performance. Once service dependencies are understood, it is possible to estimate the AWS cost associated with lifting and shifting this service. Next, enterprises identify the right service candidates for migration based on their current performance on-prem and estimated costs of running the apps in AWS. The best candidates for cloud migration are services that perform well on-prem and could benefit from cloud elasticity and on-demand scale at a reasonable migration cost. Once all the service dependencies are well understood, it is also possible to develop the appropriate compute, network storage, and other relevant service infrastructure in AWS that are required to migrate these services. Now, on day 1, the actual workload lift and shift and migration takes place. While many of the service workloads are migrated, the typical environment will still remain hybrid. with some workloads always staying on-prem and others migrated to AWS. On day 2, post-migration, once the service workloads are migrated to AWS, it is critical to continue monitoring and optimizing their performance end-through-end across the hybrid cloud. The visibility challenge is enabling enterprises to balance between service performance, measured by user experience, high availability, and reliability at scale, and cost associated with using cloud, compute, network, storage, and other resources at scale. Once this balance is elastically achieved, it is important to be able to communicate and report to the corporate business decision makers the measured user experience and cost associated with running these services in the hybrid cloud. The right level of visibility would enable enterprises to optimize the performance-cost ratio while assuring a delightful user experience across a hybrid cloud environment from a single pane of glass. This actionable intelligence empowers enterprise IT to make informed decisions regarding the optimal compute, network, and storage resources required for their services. Once the optimal performance-cost ratio is achieved, adding additional resources would be a waste, since it would not help to improve service performance. Turning it over to Ray now to cover the core technologies and practical use cases for hybrid cloud visibility with NETSCOUT Smart Data from day 0 to day 2.
Thanks, Michael. I'll walk you through NETSCOUT Smart Data, applying it to day 0 to day 2 and business as usual visibility, and how it fits into AWS and the hybrid architectures for service assurance and other use cases. We'll start the hybrid cloud migration journey from a practical perspective and then map that to the visibility challenges to assure user experience. You start with your applications on-prem in your private data center, and then consider your migration, taking your legacy application, lifting and shifting or refactoring them up into the cloud. Say you start with your presentation or web layer, get that closer to the users, put it into AWS, and then continue your journey, making the process more efficient. Next, you place some of your application components into the cloud or even into a co-location facility to help optimize what's going on. Now you're talking real hybrid scenarios with at least 3 domains to manage. Next, move your databases closer to the apps, into the cloud or colo, but at the same time, for regulatory or policy or privacy reasons, perhaps not all the databases can move. Anyway, this is all great. Speed, efficiency, agility through the public cloud, but your application is now spread across multiple domains, multiple cloud regions, co-location, and on-prem. So what happens if something goes wrong? Users start to complain of the performance issues or things are not working properly. Who has ownership? How can you quickly resolve issues, especially as things are constantly changing? Also, how can you measure the success of your migration project? What's the improvements of the performance after your migration? Can you optimize the services even more? Get more out of your assets? What's critical here is to empower IT to execute on this strategy successfully and safely, and visibility across this multi-domain environment is key. And visibility throughout the application lifecycle. This will help make this successful too. What I mean is, day 0, pre-migration, have visibility before. Know what to migrate by identifying application dependencies, baseline performance, and develop your migration strategy. Know what needs to move first, move it, and then prove success. Day 1, during migration. Assure performance, and as you migrate, assure that things are working properly, then fine-tune them as required. Use the performance information to identify problems before users start to complain. Then finally, day 2, business as usual monitoring, to optimize as you scale with user uptake of the services. Prove performance success by comparing with baselines. Continue to monitor user experience, availability, and stay aware of security vulnerabilities and threats. NETSCOUT provides this visibility with Smart Data, and Smart Data gives you visibility throughout the lifecycle and across all domains of your workloads wherever they reside. AWS, on-prem, colo, edge. It's what we call visibility without borders. It's smart visibility using NETSCOUT Smart Data. So what is Smart Data and how does it work? Well, it starts from packet data, ultra high definition, and it's universally available, and it's converted into smart data, effectively key performance metrics using deep packet inspection, patented technology called ASI, or adaptive service intelligence. We get the packets from the network in all environments in different ways. For example, in the data center and colo, they may have VMware, NSX for example, and we can leverage VMware service insertion technology to get to the packets. If it's not NSX, it might be VMC on AWS or on-prem ESXi. It might be Hyper-V, OpenShift, KVM, or even bare metal servers. And for those, we can leverage port mirroring and spans or taps. We can even leverage some of the NETSCOUT aggregation switch technology to bring packets in from multiple sources. Of course, for AWS, we can leverage VPC traffic mirroring, a very powerful mechanism to drive packets to NETSCOUT technology to be converted to smart data. Additionally, we have other cloud-native technologies so that we can even be deployed to gain visibility in VMs, containers, and Kubernetes pods, of course CKS, even where VPC traffic mirroring may not have coverage. As I said, packets get converted to smart data using vStream, our virtual appliance deployed through the marketplace. This smart data is then leveraged by our nGeniusONE service assurance platform. More of that later. Or, of course, we can just export to data warehouses and lakes through Kafka or REST to, say, Redshift, S3, and so on, for you to do with as you will. I have some ideas of that later on in the presentation. Anyway, smart data is a rich source of information. Firstly, it delivers key performance metrics. Also, sessions stored for each transaction and packets for forensics or for evidence if there are issues with the applications for DevOps escalation or, of course, infrastructure, perhaps for network or vendor escalations. ASI delivers a bunch of key performance metrics such as application responsiveness, success, failures, and errors, and network responsiveness. So smart data has the power to distinguish between the network being slow, say traversing data centers or hybrid, versus the application or database server or microservice being slow. We do this to layer 7 per protocol per message on hundreds of applications. URLs, gets and puts, database selects and drops, DNS queries, Active Directory logins, you name it, it goes on. ASI also includes a comprehensive set of metrics for voice and video analysis, MOS, cross mismatch, single direction calls, and so on. Plus, ASI can deliver security insights to identify weak security practices such as weak ciphers or early TLS revisions, certificates expiring, and more. This smart data delivers visibility for smart application troubleshooting and monitoring, and smarter analytics. With the nGeniusONE platform, smart data delivers a common situational awareness. Let's face it, we can use the smart data for network, application, and security use cases. Here's some built-in nGeniusONE workflows, from dashboards presenting the 40,000 feet view, drilling down to service monitors for specific applications and server troubleshooting. Service dependency views to visualize the dependencies of the apps and servers discovered. It has traffic views to observe data patterns and volumes over the infrastructure. It has a comprehensive reporting capabilities, but like me, if you don't want to look at all those daily or weekly reports or live dashboards, then you can take a look at the alerts, baseline, threshold, or root cause analysis. Say a server slowing down compared with normal baselining because of an increased number of sessions going on it. Then there's certificate analysis, seeing through the packet data and establishing views of the TLS handshaking. Finally, search and packet forensics. So powerful you can just search on anything, IP addresses, apps, protocols, and interfaces to quickly get to the connection information, who they're talking to, what they're doing, and of course, performance information. And then even drill down to get to the packets for the forensics. As I said, we don't throw away the packets. They're stored in vStream, ready for if they're needed to provide evidence. Now, let's put smart data to work through the phases of the migration lifecycle I talked about earlier. Day 0, baseline, checking the performance of the application in the data center before migration and seeing the dependencies and what needs to be migrated. Fix issues so you're not lifting and shifting what's already broken. Then, day 1, vStream deployed in AWS extends the visibility to the workloads migrated. It provides information to quickly identify and fix issues during the migration, say slow app server, an application which is generating errors, or bad or slow connection to the database server, perhaps still on-prem. Then confirm the performance improvements over the baseline, and, if necessary, optimize the performance of the cross-domain interactions of the hybrid environment. Say, moving the database into the cloud closer to the apps or users. Makes a lot of sense. Then, as the deployment evolves, include the addition of colo facilities in the mix and connection into SaaS services. Continue the assessment to optimize the application and service performance against the previous baselines and, of course, new business service demands. Even with SaaS services, which may be out of your control and in a different domain, if there is a problem, smart data can make you aware that your users are suffering problems because of it. You can provide the needed proof, KPIs, metrics, and evidence, even packets to help your provider quickly resolve the issue. I've known this to happen on numerous occasions where smart data has identified issues even before the provider was aware of them. And here's the result, with the apps distributed across the domains. NETSCOUT delivers visibility without borders, and nGeniusONE service dependency helps you visualize how these applications are communicating across the different borders. What's special about this is that each of the connections represents the actual communication and performance metrics of the server-to-server communication and does this by application. And we can use this to investigate what's going on. It helps you understand performance bottlenecks. To illustrate this, as we expand the previous service dependency view, we see an app server now migrated to EC2, but the database it talks to is still on-prem, running in this case across a VPN to the data center. By examining the connection between these servers, smart data reveals the responsiveness of the interaction. Response time 143 milliseconds, 88% categorized as slow responses. If you ask me, that looks as if it needs optimizing. So the database got migrated. And new performance metrics much more impressive. Response time 3 milliseconds and no slow responses. Nice, proof of the performance gains by migrating to the cloud. Proof that with NETSCOUT visibility and nGeniusONE, you're armed with tooling to help you migrate to AWS with confidence. Now, as I said, nGeniusONE has workflows to help for service triage and performance analysis day zero onwards, and has a consistent top-down methodology to see what's going on, from dashboards to service monitors to sessions and to packets. Here's this in action. The nGeniusONE Hybrid Cloud Dashboard, a view of common situational awareness for NetOps, a network view, DevOps, application view, and an infrastructure view of AWS, data center, and colo into the separate domains. For a DevOps view, a look at all the tiers or microservices of the application, wherever they reside, the front end, the app layer, the database layers, Active Directory, DNS, and so on, each an essential part of the overall working application, and each of the dependencies critical to the performance of the application as a whole. And we can drill down into each layer to examine the specific performance. Here's the MySQL layer, showing the smart data on all the MySQL servers or services, whether EC2, RDS, on-prem, or wherever. Showing the latency of the transactions, the number of transactions and the failures by servers, plus detailed performance graphs of server latency, errors over time in the context of the database transactions. Once a server has been identified as being interesting, it's slow or has a lot of errors, we can examine the individual sessions, ladder diagrams of every query, every MySQL interaction in this case. And if necessary, drill down to the packets of the queries. Of course, revealing the query and the errors. But remember, we had the information on the failing server or service at the top level and service monitor. The packets just provided the ultimate evidence, and the KPIs did their job to get us to the root cause quickly. Also, the thing is, this same workflow works for any application smart data is monitoring, no matter where the workload resides. And take a look at this architecture model. I know it looks complex, but it amounts to NETSCOUT, nGeniusONE, and vStream virtual appliances deployed in AWS through the marketplace. It has scalability and failover built in, with global managed local and standby servers, and can be distributed in AWS, on-prem, in colos, anywhere. In AWS, vStream typically receives the packets using VPC traffic mirroring applied to the EC2 instances themselves, or by leveraging VPC ingress routing or even the new AWS Gateway Load Balancer technologies, where we also leverage VPC traffic mirroring, but this time on the appliances conditioning the traffic, destined to the other EC2 instances or AWS services we want to monitor. Anyway, drop by our virtual booth here at reInvent and get some virtual demos so you can be able to take a look at nGeniusONE in action, deployed in this type of complex AWS environment. These go much more in depth than I can cover in this session. Okay, so we've gone through AWS deployment architectures, day 0 to day 2 service monitoring, troubleshooting and performance optimization with nGeniusONE and Smart Data. What about other use cases of the Smart Data? How about cost assessments? Remember, we're tracking through the packets, every interaction of the servers by application we're monitoring. So using this, we can see instant costs by application based on traffic usage. I can think of a number of good applications of this. Obviously cost analysis, but what about cost departmental recharge of the network services? And of course, for summary reporting and intelligence, take the exported smart data to your data lake and combine it with Amazon CloudWatch metrics, and you get infrastructure performance, service and application performance all in one view. Again, another set of interesting use cases. So we've covered the hybrid cloud migration journey, day 0 to day 2, assisted with smart data visibility to assure user experience, optimize services, and provide continuous monitoring in the ongoing AWS journey you're making. Now back to you, Michael, to talk about more forward-looking things with smart data as our customers too continue their AWS journey.
Thank you, Ray. Before delving deeper into the 5G system visibility, please allow me to give you a brief introduction on NETSCOUT offerings to communication service providers, or CSPs. NETSCOUT offers service assurance and visibility without borders for some of the largest mobile, cable, and fixed-line communication service providers in the world. NETSCOUT services are used by networking and operations teams of these CSPs to plan, design, engineer, operate, optimize, and monetize their services end-to-end, including the RAN, network edge, and core. NETSCOUT's visibility without borders spans across 2G through 5G networks. Specifically for 5G system visibility illustrated on this slide, NETSCOUT can decode traffic traversing all N1 through N50 reference points in the user and control planes, and convert this traffic into high-definition smart data used to deliver end-to-end visibility across both non-standalone and standalone 5G networks alike. The visibility for voice, video, and data services offers deep insight into who, when, and from where services are accessed and their quality. It also offers quick and intuitive workflows to triage the root cause of service degradations while significantly reducing the mean time to repair. In this next slide, you see how AWS helps extend enterprise 5G to the network edge with wavelength, deployed in CSP edge data center, and outposts deployed in the enterprise on-prem environment. 5G user plane and some of the control plane virtual network functions can be deployed at the network edge in wavelength, while other VNFs are deployed in AWS VPCs. Communication service providers can then use network slicing to deliver streaming video, IoT, AR, VR, gaming, and other ultra-reliable, low-latency services all the way to the edge and make them available to enterprises. NETSCOUT uses VPC traffic mirroring to monitor both edge 5G VNFs, the multi-access edge computing MEC server, and other service delivery edge elements in a similar fashion described earlier in the presentation by Ray. The acquired traffic data is then converted into smart data for end-to-end visibility and service assurance. Next, let's review NETSCOUT and AWS collaboration more in detail. NETSCOUT is an advanced technology partner with networking and cloud migration competencies. Our solutions are available in both commercial and GovCloud AWS Marketplace regions, and we are members of the AWS ACE co-sell program. As part of the technology alignment, NETSCOUT participated in several AWS launches, including for VPC traffic mirroring, VPC ingress routing, and Gateway Launch Balancer. This collaboration included early alpha and beta testing of the functionality and all the way through AWS public announcements in which NETSCOUT was featured. In fact, my co-host today, Ray Crook, tested all these technologies from the very early stages. Please visit our virtual booth at reInvent to view some of the demonstration videos on how these technologies are used by NETSCOUT to achieve comprehensive visibility in AWS from a single pane of glass. AWS and NETSCOUT are stronger together due to compelling technology alignment synergies, especially in the area of acquiring and converting traffic data into actionable intelligence for customers. For sharing the common objective of helping enterprise IT to accelerate the AWS cloud migration as part of their digital transformation plans, and for helping enterprise IT organizations deliver high-quality services to their customers and end users. Here are some of the customer testimonials from NETSCOUT Voice of the Customer surveys that reference the actionable intelligence, end-to-end visibility across a variety of services and infrastructures in the hybrid cloud, and the delightful user experience achieved with NETSCOUT visibility. In summary, strong collaboration between NETSCOUT and AWS helps everyone win. Customers win since NETSCOUT end-to-end visibility. They can now migrate to AWS with confidence while ensuring a delightful customer experience throughout the migration process. Post-migration, they can use the same visibility to optimize service performance, reduce costs, and quickly detect and resolve service issues with low mean time to repair. AWS wins since our collaborations help accelerate migration and adoption of AWS services by satisfied enterprise and communication service provider customers. NETSCOUT wins since we help our customers to navigate successfully through their digital transformation journey and help them execute their AWS migration initiatives with success. Thank you for listening.